Hi, welcome to the notes for lecture number 9, and we're going to start with some break-even analysis and get right into that. So without any further ado, we're looking again at our lemonade stand model. We're just going to throw some assumptions in here. The fixed cost is $10. We had a variable cost, which we calculated in class, of 93 cents a cup. And we came up with a selling price of $1 per cup. And the question is, how many cups of lemonade do we need to sell in order to cover off our fixed costs and our variable costs up to that unit? Everything beyond that will be profit in our pocket. So let's do the algebra first. The break-even point is going to occur where our cost is equal to our revenue. And our cost is composed of two pieces. We have a fixed cost of $10, and we have a variable cost of 93 cents times some quantity of glasses of lemonade. And that is going to equal to our revenue, which is $1 times Q. So every glass of lemonade puts $1 in our pocket. And the question is, where does this where are we equal? Where are we indifferent between our cost and our revenue? So we have our Q terms here. We can bring this across and have $10 on this side, and $1 minus 93 cents is 7 cents. So Q is equal to 10 over 0.07, which is 142.85. So we'll say 143 glasses rather than giving someone a fractional glass of lemonade. So 143 glasses is where we go from, losing money to making a profit. And we can show that graphically down here. Again, we have all our same bits. So we have our fixed cost. For the fixed cost, I'm just going to use a dashed line like this. Fixed costs are $10. It's going to be $10 all the way across. And you can see I put little hash marks on this chart so it's easy to follow. One thing I didn't do is include labels. So we have dollars up here and quantity down here. And let me just change up my, my line. Total cost, we'll pick a different color, maybe a red line. So our total cost will be here, whoops, in red dash line. Total cost at 0 glasses of lemonade is going to be just the $10. And then we can calculate some other point on the line. So I said, look, what if we had, at Q equals 200 glasses of lemonade, my total cost is going to be what? Well, it's going to be $10 of fixed cost plus 200 glasses times 0.93 cents of variable cost. Whoops, this is $186 plus 10 is $196. So my total cost goes like this. There we go. So this is my total cost line right here. And what we're going to do is we'll do the same thing, and we will come up with a revenue line. Let's make this one green. And a revenue line, oops, I keep doing that. There it is. At 0 glasses of lemonade times $1 glass, we have $0 of revenue. And at 200 glasses of lemonade, we have $200 in revenue. So again, we can just connect the dots. There we go. And you can see our break-even point is right here. So this green line here represents our revenue line and our total cost line. So down here, our total cost in red exceeds our total revenues. Up here, our total revenues in green exceed our total cost. So up here, we have a profit situation. Down here, we have a loss. And right at this point, we have our break-even point. So let's pop that in. What's a nice purple for break? Or pink is a nice color for break-even point. There we go. And line it all up there. And we said it was about 143, and indeed, whoops, that's what we've got down here. So our break-even point was 143. There you go. What we do in the next one is we do a what-if scenario. What if we bump the price by 25 cents? What we'd expect to happen is this break-even point to slide down this way. The number of glasses of lemonade we have to sell at the higher price will be less than 143. That we'll start making profit earlier, assuming, of course, we can sell it. And the mathematics is really easy. Again, total cost of 10 plus our variable cost of 0.93 times however many glasses of lemonade we sell. And we want to find out where we're meeting up with our revenue of $1.25 per cup of lemonade. So 10 on this side, $0.32 or 32 cents over here times Q. 10 over 0.32 is equal to Q, which is equal to 31.25 glasses of lemonade, but nobody wants a quarter of a glass of lemonade, so we'll just call that 32 cups of lemonade, which is less than 143. So there we go, much like we expected. And again, we can connect the dots. So let's draw the same lines on there that we had before. We'll start with our. I keep doing that, don't I? There we go. We will start with our fixed cost line, and I'm not going to go into as much details because you've seen it on the previous one where we went into lots of details. You can follow along. We will do our total cost line. We'll do that guy in red. Total cost, again, starting at 0 and go up to 196. And we'll do our revenue line. Pretty sure we used green last time. There we go. So revenue, 0 cups of lemonade, 0 revenue. And now, at 160 cups, we'll have $200 worth of revenue. And that's our revenue line. And then finally our break-even point. I used pink last time. There we go. Our break-even point was down here at 32 cups. There's our break-even point right there. So again, up here we've got our green line, our revenue line exceeding our cost line down here. Our cost line exceeds our revenue line. So we have a loss in here, and we have profit up here in this part. There we go. And again, this is quantity of lemonade, number of glasses, number of cups, and dollars on the vertical axis. And we had a couple of questions from old final exams. The trick to this one is this 90% factor tossed in there, but it's pretty straightforward. We have $200,000 per room times 1 over $250 per room per night. Dollar signs go away, and we get 800 nights. Now we have this 90% factor. The 800 would be if we're at 100% of our capacity. 800 divided by 0.90 gives me 888 rooms, or sorry, nights. And we need to transform that into years, so we have 888 divided by 365. That will give you roughly 2.4 years. So it'll take 2.4 years to realize your investment on your hotel fixed cost. The trick to that one was the 90%. And the last one is looking at waffle cones, make versus buy. A lot of students were wondering when, why don't we have any information about the cost of the ice cream cone? The answer is it doesn't matter. You don't need to know the price of the ice cream. So if we're making the cones, it's $500 plus 2 cents per cone. And if we're buying, it's 7 cents. So we have 500 plus 0.02 times quantity is equal to 0.07 times quantity. And we can figure out this is 500 over 0.05 equals Q, which is equal to 10,000 cones, which is this answer here. So between 0 and 10,000 cones, we should buy them. And beyond 10,000 cones, we should make them. And there we go. And I'll leave that there for the fill in the blank part, the first part of the Lecture 9 notes.